Hi there. In today's lesson, we're going to look at heats of fusion and vaporization. We're going to start with a solid. Okay, so we'll draw our standard solid, which is this kind of 3 by 3 cube. And we're also going to draw out our liquid. And again, you've seen drawings like this before. I've drawn these guys out many times. Okay. So if we said that, let's say this is ice, and you have water over here. We know that by adding heat energy, okay, so if we heat up the ice, what happens is all that energy from the heat causes the atoms to vibrate more and more. Okay, so this is what we call warming. Whenever we want to find heat due to warming, it's always our CP formula. Okay, so Q equals M delta TCP. But at some point, if we add just enough heat energy, bonds will start to break. So if we broke the bonds that connected those particular atoms together, you'd end up with water. So it's not as easy as just that though, okay? Because at one point, the energy that goes into the object will stop it from vibrating any further, and then it will switch over from vibration to bond breaking. That's the part that we want to figure out. We want to figure out how much heat energy it actually takes to transition from ice to water. Okay? And in order to figure that out, we need a formula called Q equals mass times heat of fusion, which we abbreviate as Hfus. Okay. So what is heat of fusion? Okay. This is just the amount of energy needed to phase change between solid and liquid. So whenever you're going between a solid and liquid or liquid and solid, you're always going to use heat of fusion. So for water, H of fusion equals plus or minus 334 joules per gram, because it's based on mass. Okay, and that's only for water. If we are converting between liquid and gas, we use heat of vaporization, or Hvap. Okay. And Hvap for water is plus or minus 2,260 joules per gram. So why is it plus and minus? Okay. To go from solid to liquid, that process absorbs heat. So heat has to be absorbed. You have to add heat in order to melt ice into water. Therefore, your H of fusion is positive 334 joules per gram. But if you're going from liquid to solid instead, okay, if you're freezing, then heat is released. And if heat is released, your H of fusion is a negative 334 joules per gram. So if we go back to this little diagram up top, we're trying to figure out how much heat energy is required to go from ice to water, okay, to have this phase change. Well, in order to figure that out, we need heat of fusion. Okay. In particular, we need this formula right here to figure out the amount of heat involved, okay, to figure out how much heat is needed to break the bonds so that it can turn into water. So if we look at a calculation now, okay, let's say example, how much heat is needed to change 100 grams of ice into water. Because we're looking for heat, heat is Q. The 100 grams is our mass. Okay, so that's the mass of ice that we need to convert into water. So because we're going from a solid to a liquid, you have to absorb heat. So we're going to use positive 334 joules per gram as our H fusion. So you'll notice that grams will cancel out, and what you're left with is just the unit for joules. So this should come out to be about 33,400 joules. Positive. So this is how much heat is absorbed. During phase change. Notice that there's no temperature change though, right? we're only concerned about where the energy is going to break the bonds. So similarly, if we actually did the reverse process, right? This is the melting stage. Okay. If we looked at freezing, it's still the same formula, 100 grams, but because we're freezing, we have to put the negative sign in front because we're releasing heat. And the value is exactly the same, but now instead of absorbing heat, you're losing 33,400 joules. Okay, so this is released during that phase change. Now, there's one last interesting point here, okay? Because during all this phase changing, okay, like I mentioned before, that temperature doesn't change. Okay, so during phase changes, the temperature of the substance does not change. And if it doesn't change, then we have one specific melting point, freezing point, boiling point, or condensation point, right? The temp is constant at a substance's melting point, freezing point, boiling point, or condensation point. Okay. So that's why at 0 degrees Celsius, oops, my eraser doesn't seem to work. Oh, there you go. So at 0 degrees Celsius, we have both solid and liquid, okay, which is the melting point / freezing point for water. Okay, and because if you're melting something or boiling something, okay, once you reach that temperature, nothing else will burn. The only thing that's happening is phase changing. Okay, so the only thing that's happening with all that heat energy that you're adding in is to actually break or form bonds. Okay, so all kinetic energy is used to break bonds during melting or form bonds during freezing. Nothing else happens, okay, to the substance in terms of its temperature.